Thank you. Let's go to our next speaker, Zeynep, who will be talking about non-functional quality aspects. Zeynep, over to you.
Yes, okay. Hi, everyone. I'm trying to share my screen now. Sorry. Oh, sorry for that. I have just uploaded the app and it requires some permissions. I will be quit and rejoin again. Sorry for that.
Sure, no problem. In the meantime, if anybody has questions for Mana and Marina, this is the time.
Don't be shy. I don't bite on Thursdays.
By the way, Mana, I did have a question
Oh, yeah,
about. Can I ask a question too?
please do.
I wanted to hear your opinion on accessibility testing. Have you seen that there's a bigger focus on accessibility testing in bigger companies compared to startups? Or is that not true?
I'm not super sure about startups, but I feel like the mentality in startups, is 80-20, right? So accessibility usually falls into the 20, I think.
Yeah.
And speeds, do everything fast, do it now is kind of like the vibe that I get from startups. So
Yeah.
I think things like testing and accessibility can often be like,
Yeah.
we'll deal with that later. We just need our product up, right?
Yeah.
And I think big companies have more money to invest, but they also have like more loopholes to go through as well. So I think probably like the sweet spot is like a mid-sized company where they have a good amount of people and resources and not too many red tapes to go through to make things happen.
Right. Makes sense. Cool. Thank you. And Zeynep, we can see your presentation.
Yeah, I'm starting. Hi again, everyone. Today I will be speaking on non-functional requirements of a software system. Usually, even customers are not aware of them, but there is a tiny nuance because it's only until the first failure. After the first failure, they know them, they know what the non-functional requirements means, and they will be aware of them. But of course, it's the worst case. If the customer knows about them, it means it has already failed and it has already seen the failure. So as software developers or software testers, we should keep them not being aware of these requirements because it's related to how system works rather than what the system does. Before diving deep into the topic, let me introduce myself. I'm Zeynep. I'm working for about 10 years as a software developer, mostly worked on backend development. And except then software development, I have worked as an ICT expert for Information and Communication Technologies Authority in Turkey. It was a bit related to this topic because it was a regulation authority. So, and compliance is one of the non-functional requirements of a software system. Working for an ICT authority helped me a lot to see that almost every system should meet some requirements, even the customer doesn't expect them. There may be some rules or regulations related to the software field, and it may affect our system, or it may affect even our functionality of our system. And except than that, I have written a book on software development quality topic in Turkish, including basic software development techniques and terms, and the ways to keep quality by applying some refactoring techniques or some tools. And that's all. The scope of this presentation is about user expectations and non-functional requirements and their effect on the overall software quality. To get better understanding on non-functional requirements, we should understand and try to learn the needs of the system. They may not told us by customers, but we should foresee and fulfill before they ask or before a failure happens. They may not be told because of several reasons. Maybe users don't know about them, or maybe they can't explain, or maybe they assume that the requirements will be fulfilled by default, even they don't explain it. Because they may think that everyone knows it, but maybe in their domain, everyone knows it, but as a software developers, we may not know some domain informations. It's like that when you go to a restaurant and order a meal, you expect that a spoon or fork, or an appropriate utensil will come with that meal, even you don't say anything. If you don't bring that spoon or chopstick or knife with that meal, there will be a problem. We can say that the customer hadn't told that. So trying to figure out these requirements that everyone accepts but may not be told is necessary for developing high quality systems. And there's an explanation of software quality. It can be defined as the measure of meeting expectations and degree of excellence of a system. So we can say the more system meets the expectations, the more quality is. But these expectations is not only the user or customer expectations. I will quickly pass that
Sorry
one.
for interruption, Zeynep. Are you moving the slides? Because we are seeing the same one.
Really?
And now
Oh.
it changed. Yes.
Would you, had you seen that slide?
Now we see the scope slide.
Ah, okay. It is now on the slide.
Software quality.
Yes, yes. When should it be handled? Quality may be taught as a single step in software development cycle, as QA step, but it should not be taught like that. It should be handled in each step of a software development cycle. And who should be responsible for that? Of course, not QA only. The whole team, every person in team should be responsible. Some part of quality aspect or non-functional aspect of the system. And we will be focusing on fulfilling non-functional requirements and user expectations in software development lifecycle in this meetup. There are 4 basic steps, as you know, in a development cycle: analysis, design, implementation, and testing. In the first step, requirement analysis, we focus on user expectations rather than functional requirements. The requirements in this step generally like that when user clicks on that button, a report file should be downloaded, or at the end of each month, a new notification email should be sent to the user. All of these can be taught as functional expectations, functional requirements. And these these sentences tell us what the system should do. On the other side, a software is not a combination of these functional requirements. There are some additional requirements that users not expect. For example, a customer may request a login page with email and password, but they don't request saving the password after hashing the text with a secure algorithm to make the system more secure. It should be taught by a software developer, and it should be implemented by a developer. Or they can expect sending emails each month, but they generally don't tell that if the email sending was failed, retry again 3 times, or retry something to fix that, to make the system more robust. Actually, there are some default expectations that a customer has, and non-functional requirements may help us on understand them better. Non-functional requirements functional requirements is what the system does, but non-functional requirements is more related to how system do that action, or what the system is supposed to be. There are lots of aspects as compliance, maintainability, efficiency, etc. That a software developer should be aware of to develop high quality software. It can be related to the system usage and fields. We don't always need to implement all of them. For example, here we have portability. It means the ability of running on different platforms of that software application. But if our system will be used on a personal computer, or if it will be used by a single user, we don't need to spend much time or effort to make it scalable or portable. So these non-functional requirements can be prioritized by the system needs. Sorry. And in this presentation, we will be going on this 6 of them. In sum, compliance means the appropriate of the system to the rules or regulations on the area the system will be used. It can be changed by location or some rules in that location. Extensibility means being able to easily adopt new features or easily develop new features on a software system. Readability, having an understandable and simple code base. Fault tolerance, being robust on errors or exceptions, or the ability of handling exceptions and continue running even an exception occurs with an alternative flow or doing an action for that fail. Testability, it means having easy to test code base, or a modular system that makes it available to test part by part of that, the system. And the last one is security. It's implementing data protection and being ready for the external or internal attacks. Or after a possible attack, the ability for restoring system data and get back running in time. It's an example for compliance. It means the appropriate of the system for laws or regulations for the audience. It may be different for each country or region, For example, there is a GDPR regulation for EU to protect personal data and privacy. It's the reason that we should click one or two times, one or two buttons when we need to read a blog post or when we open a new web page, because almost every web app should keep some data, some user data on cookies to improve user experience. But because GDPR makes it a requirement, the system should implement it. Even customer doesn't need it, or even customer don't want to add it. Because of these rules, we should implement it, and we should make this. We should implement this non-functional requirement in our system. The second one is extensibility. Extensibility is more related to software development step. It means that the code base should be developed easily, and new features can be added, can be implemented easily. It's needed applying clean code principles like solid and separate responsibilities of each code part to make a code base extensible and simple. And to protect clean code, we should also apply code refactoring techniques and doing some cleaning tests once in a while. There are also some programming language specific features like polymorphism to make a system easily extensible. In some, it provides a structure to create more generic structures, and there's specific subclasses. And by adding a new specific subclass, the whole code base can be working for this new feature. So we can add a new feature by adding only one subclass of an existing system. It seems more related to a developer responsibility. Readability is a bit related to keeping code base simple and easily understandable. It can be taught as a developer work, but it may affect so many things in the team or system. For example, a new developer can adapt easily to the code base and start producing new features in short time if the code was readable enough. And there are some key points like following naming conventions or extracting methods to name them and make them more understandable. And readability is easy to explain but hard to implement because features or code base are changing in time, and it's hard to keep these changes simple. And there's one more thing related to it. It's important to speak with the same language and using the same terms in the team and with all participants in the project, because it makes it easier to find an issue or find a place to fix when an issue occurred or a new feature will be added. We can find it easily, so it can decrease cost of the project. Fault tolerance, in some, it's being robust and strong in case of any fault or any exception. It can be reached by handling exceptions properly, improving alternative flows after any exception occurs. It can be done in many ways. For example, retrying an action again after a failure, or doing the database operations in a single transaction so that when one of them fail, we can revert back the others together. And it can be logging or emailing to an admin related to the issue. These all actions improves fault tolerance of a system. And even we don't have any action to do in this fault case, the system should inform user properly, and it's important not staying still or canceling the action without giving any information. And testing fault tolerance of a system is also important. The edge cases for getting exceptions and the actions should be done after this exception should be tested to make it more robust and keeping the system fault tolerant. Testability is important. It's important to write testable codes, especially for unit testing. We send an input to a function and expect some returned values, or we can check some changes made in this function in background. But some functions cannot be tested easily. For example, if an I/O operation made in this function, for example, function reads a file in the system from a static path and do some actions. To be able to test this function properly, we may need to change the file contents, or we may need to try some different cases for the file. But if this function doesn't take any parameter for the file name or file path and uses the strict file on that system path, it cannot be tested easily. So it should be replaced by another file on testing. Maybe we should parameterize the file name for this function to make it testable. Or another case is dependencies between classes. We should use dependency injection to be able to change the dependent instances on testing. So it's important to write code to be able to make them more testable. And security is the last one for that slide. It's another aspect that user needs, but not tell us. It should be handled in a wide range of the software system. Starting from analysis, development, testing, all of these steps should include security in their flow. For example, a user, as I told before, a user may not clearly explain that password data should be hashed with a secure algorithm, or which algorithm should be used. But it's expected naturally to keep passwords secure. On development side, there are some methods like implementing code refactoring to decrease complexity, or using up-to-date algorithms for hashing, because even it was a secure algorithm in the development time, it may become not secure in today's technology, because it's developing and some secure algorithms are outdated in time. I think the hardest part of software development is handling the changes like that and updates and applying updates in time. A new change may break an existing security protection, so it's important to check them periodically. There are some tools to check security issues and get some reports weekly or monthly. Here is a link, but I can share in chat. also. And thanks, that was all for my presentation. It's what it taught by getting the customer needs. Like I will go out and find out what they need, and the rest of you start coding. But it's not an ideal case, and system requirements should be taught as a combination of customer needs, customer expectations, and non-functional requirements. A developer or tester should be able to extend the requirements by thinking non-functional requirements and including their expertise on that field. And learning these non-functional aspects can help on better understanding customer needs or preventing failures before they happen. And yeah, that's all for the session about non-functional requirements. Thanks for listening. And it's my first English presentation for an international community, so it's special for me. Thanks for inviting me there. That was all.
Thank you. Thank you so much, Zeynep, for your presentation. We do have a few questions. The first one is, are there any AI tools for non-functional testing?
Generally, in development side, there are some code quality tools like Sonar Cube that we can measure if the code length is too long, or if the class has too many parameters that we can't understand what is going on in that class, so that we may break something easily. So they measure the code quality on some metrics that we can configure, and then they can report them us, so that we can improve code quality. They may be used on code quality part. There are also some AI tools to help us on writing code and making some suggestions on ideas, development environments. For example, in IntelliJ IDEA, there is a new update with an AI tool, so that it can improve code quality in time while we are writing. And yeah, that's all.
Thank you. There's another question. How do you convince developers to care about customers?
It's a good question, I think. As a developer, actually, I'm a backend developer, but I have always good relationship with test teams because I understand. But in general, as I can see, it's not always like that. Maybe developers can see testers as a how can I say, as they trying to find their faults or something like that. But it's not like that. Actually, testers are helper for developers. They help them. They help us on finding issues or not breaking the code before going to production. And I think understanding the customer needs also important for developers, because without knowing customer needs or without looking from customer perspective, we may implement something wrong and we don't realize what we are doing. Even we implement it in the most high technology or doing the most proper technology or in a cleaner way or in the best way, it doesn't mean if it doesn't meet the expectations of the customer or the other expectations that I was talking about, like regulations or rules. So it's important to understand what for we are working. We don't work for creating the best code. We work for meeting the meeting the user expectations or the other expectations like that. So I think understanding the reason for writing the codes is important to be able to look from the customer perspective.
Yeah, that makes a lot of sense. Thank you. We have one final question. Is backend or frontend more difficult to maintain in terms of non-functional quality aspects?
And I think the simple code is the most important thing on reaching the high quality code or preventing some issues on non-functional requirements. About development process, I think they're all the same. They're just languages that we use, and we should keep them simple. We can keep both sides simple in regards of clean code principles. But on backend, there are some additional aspects or additional fields to keep them secure or keep simple or check to check if there are any logs or if there are any alarms on the overall system. So maybe keeping the backend more robust or secure is maybe a little bit harder than front end, but on front end also a developer may lead some issues on security or some other aspects of non-functional requirements. So they're all important, but yeah, backend seems me more harder to keep everything okay.
Thank you. Thank you for answering a lot of questions and for sharing your thoughts on non-functional testing. I think that's all for the questions we have. I think we can wrap up here. Thank you so much to all the speakers, Zeynep, Mana, and Marina today for sharing your insights. I think I learned a lot, and I'm sure everyone learned as well. Let me share QR code for Japan Test Community on Slack. And we will also have a conference. Tokyo Test Fest is happening on November 15th. So please sign up now. And I think early bird tickets are still available, right, Mesrud?
Yes, it will be available until the end of September.
Oh, great. Okay, so please sign up. Thank you. I think that's all for today. Mesrud, did you have any closing comments?
No, I also enjoyed a lot the talks on different aspects of quality. Non-functional aspect, accessibility is also a non-functional aspect. And even the quality mindset and guiding or teaching this to juniors or other people, all of them were great, a lot of insight. So thank you so much for the speakers. And thank you to our moderators too, you and Ayame. It was a great event. Thanks.
Thank you all. Have a nice evening. Bye-bye.
Bye-bye.
Thank you.
See you.